allow me to briefly introduce all of our panelists. We're very grateful for them taking their time to be here today. Our first panelist, I believe it's 4 p.m. for her, and she's on summer break. So you educators know how valuable summer break is. And so thank you to Rachel Isles for being here today. She is a curriculum leader of design and technology at Ilkley Grammar School in the UK. She has a master's degree in industrial and product design. She spent a lot of time in industry, and she's now an educator, and she has students as young as, I believe, 11 years old, doing some pretty advanced CAD and advanced manufacturing and design. So exciting to hear from her today. Welcome, Rachel.
Thanks, Matt.
Next, we have Chris Rogers. Chris is a founding member of the Tufts Center for Engineering and Education Outreach, which helps thousands of teachers and reaches out to thousands of teachers to increase opportunities for students. Chris served 7 years as the chair of mechanical engineering at Tufts, 5 years as mechanical engineering chair at Tufts. Correct me if I'm wrong, I think he taught in Switzerland, was a professor of distinguished teaching at Princeton, Fulbright Scholar in New Zealand. His CV is long, so we're very grateful for Chris joining us today. Next, we have Philip Tabor. I am tempted to start with Philip asking you to explain that whole high energy laser fusion thing that John McElhaney was talking about. If we have time, maybe at the end, we can get into that. But Philip is the VP for hardware engineering at Silverside Detectors. Silverside Detectors is a company that uses cutting edge physics to do nuclear security and water resource management. I think my favorite Philip Tabor fact is he was the lead project designer at Jetboil. If you hadn't heard of Jetboil, walk into any camping store and ask them for their coolest camping stoves, and you'll be pointed to those like lightweight, fancy camping stoves. That's Jetboil, pretty cool stuff. So thank you, Philip. And then finally, only alphabetically, we have Steve Vasilov. Steve has been described as the Steph Curry of STEM education. I don't watch basketball, so I don't know what that means, but it might mean something to do with racking up lots of trophies and accolades. So hopefully we'll hear some more about that today. Steve is a teacher in Saline, Michigan, and he teaches a whole host of classes, including engineering, advanced CAD, computer-aided manufacturing, and a bunch of others. His students have a knack of racking up national awards at all kinds of competitions. And so hopefully we'll hear more about that today. So I'm going to start by directing a couple questions to people individually on the panel, but of course, the rest of the panel is invited to interrupt, chime in, add their perspective, whatever. But we are going to start with Chris. Chris, we're going to go big picture. I want to start big picture. Everyone on this panel has spent a good deal of time in education, and you're no exception there. I'd be curious just to start with your philosophy on education, your thinking on the purpose of education, why we're all here today, really. And especially if any of that thinking has evolved over your time as an educator. Are we just cranking out the next generation of widget makers, or is there some higher calling that we're all here for today? Yeah, just your kind of thinking on the responsibility and power of education in society to change lives. I know a lot of your research has to do with this, so not to go too big, but love to know your thoughts. Start with Chris, and again, like I said, anyone else feel free to chime in.
And you want this in 2 minutes or less?
2 minutes. No, we have like 40 minutes, so give us a summary.
Right. So I happen to be a big fan of widget makers. I've bought a ridiculous amount. I think that's what Kickstarter is, right? But other than that, I'd say that a lot of the work we do is trying to get more of a balance in education between learning the knowledge of others, which is understanding Newton's laws, etc., and then learning how to learn on your own. So the difference between what you think is causing you to fall down the steps versus what Newton thinks is causing you to fall down the steps, and how do you bring those two things together? So I'd say in most education systems we work with, they're very good at the first, and those are tested with standardized exams and maybe aren't quite as good as the second. So how do we really get students to start driving their own learning and give them the scaffolds they need as they go along to start figuring stuff out? I think we do this pretty well in sports. Not many people read books on how to swim before diving into the deep end or being tossed into the deep end, but we might not do it as well in the sciences or in the mathematics or engineering.
But with the right supervision and maybe some floaties, that is probably the best way to learn how to swim. You can probably read books on treading water all day long without actually learning how to tread water. And then when you're at, often what I found myself doing, then I'm at home trying to do my homework by myself. And that's when I drown because I don't have the scaffolding or support of my teacher. Any other educators on the panel have experience with kind of what Chris was saying, teaching their students to be self-driven, to be the self-learners, to be the intrinsically motivated learners?
Yeah, I guess I have, in the respect that because I teach from 11 years old, which is what we call year 7, which is the start of secondary in the UK, right through to age 18. And we've pretty much introduced Onshape across all those year groups in the last 2 years. The year 7s and year 8s, which is sort of the 11, 12, 13-year-olds, react quite differently to the older groups. Sorry, ignore my clock. Now, the young ones, because Onshape has that magic ability of being able to be used on an iPad, they just take to it like a duck to water because they're so used to using the iPad and not using a mouse and a computer. They can just straight away start using that 3D space, and they're much quicker than I am picking it up. I can any day put me in front of a computer and a mouse and I can use that really well, but going onto the iPad, they're much more intuitive with it. And I think that giving them the freedom to be able to access it how they want to actually allows them to learn a lot quicker. We found with ours, what I've tended to do is actually record little videos of certain tasks I want to do. So they learn through watching me maybe do it on the board, maybe sometimes doing it right and doing it incorrectly so we can all backtrack as a class. And then I then provide them with a copy of what I've just taught, but then again on a video so they can backtrack and go through it at their own speed and realize where they've tripped up, and maybe they can just then double check. And we find that's quite good with the younger students. I'm always looking out for top tips with the older students that tend to block and go, I can't do it. And that's a sort of thing that we're working with our older students, is just easing them in, but getting them to work on the computers and sometimes crossing over to iPads as well. I find they're not quite as intuitive as the younger ones are. So yeah, it's interesting. I think Steve, because you teach the sort of age 14 and upwards, you might have a slightly different experience with yours. I don't know if you have access to the iPads or not.
We do have a lot of experience with that as well. I have a lot of students who actually will transition from a computer over to a tablet or even over to their phone. I have a lot of students that end up getting jobs in industry, co-op positions, internships, and I've had students submitting work from their cell phone while on a break at work. So they are doing it in my classroom, going to work, working in a field, and then they're actually on their break completing assignments for me and submitting them from a mobile device, which is quite amazing at this point. And the accessibility piece is really what sets Onshape apart from a lot of the other softwares in industry right now.
Yeah, completely agree.
I wonder if that's part of the secret sauce to allowing students to be self-directed learners, is allowing that choice. Like Rachel, hearing you say that the students are natural on the tablet or even the phone. When I first started doing CAD, and also when I started doing Onshape, the first thing I did, well, all my students had school-issued Chromebooks. And when we started with Onshape, I was so glad that we could move to Chromebooks, that I could dismantle my expensive computer lab and go with the cheap Chromebooks. But the first thing I did was buy 60 mice for my lab. And I told the students, you can't do CAD without a mouse. So I had all the kids plug in their mice. And then I watched them plug in their mouse because I said so, and then leave the mouse on the next to them, and then just use the trackpad to do the CAD, or flip it over and use their finger. And I think my teaching experience was largely letting go of my biases and what I want them to be doing and how I want them to be doing it, and letting them explore in their own way. And yeah, maybe it's those 11-year-olds that haven't been hammered into a mold yet.
Yes, yeah, I think you could be right. Maybe we need to be taught by them sometimes and just be led. But I think that's the magic of Onshape, is that it does give you the options That, I mean, to go onto a mobile phone and change a CAD drawing, it's just insane, but it's perfectly possible, and that's kind of the magic. And I think it's just bringing all those people through and getting them all on board with that.
I remember being excited that I had a mobile phone that I could just receive emails, but I would receive an email and I'd look at it and go, well, I'll have to wait till I get to my desktop to reply, because no way you can do an email on a phone.
Yeah, exactly. They're so lucky, aren't they?
They have no idea. If no one has any further comments, Philip, any thoughts on?
I'd say it's fun listening to.
Oh, we lost your audio. I think we lost Philip's audio.
Guess you're going to have to read lips.
I'm trying my best.
Let's try this again.
There we go.
There we go. Right. So I think it was fun listening to the previous session, because I will have my phone out in the shop at Silverside, or we've been known to pull a tablet out to take a look at a design. And then on occasion, when I've had to go back and use another traditional CAD program, inevitably, I want to go to the machine shop and build something that I've just been designing, and I realize, oh, I need to check a dimension, or something is not quite right. And so the ability to take the design media and put it in the same space as where you're going to be fabricating and testing something, that's a capability I didn't have before. And it's something that, in the stories that I'm hearing about the students in the school, is going to translate straight into things like people like me are doing, where taking out that friction of, hey, I'm trying to design this, it didn't quite work, I need to make a change or check something. Being able to have that at the fingertips is fantastic.
This is a little bit of a side note, but I love hearing mechanical engineers share stories, because they can't help but injecting metaphors from mechanics. And so, yeah, hearing John use friction, heat loss due to friction. And so trying to remove heat loss due to friction from systems, and you're putting all your energy in, and if it's all leaving the system as photons, right, it's a waste.
And Matt, you had mentioned earlier, Matt, the idea that you drowned when you got home, and when you didn't have that teacher or that person to assist you at home, you struggled so much. And I think that's part of the beauty of Onshape, is the idea that I've got students that will get stuck and send me an email at 6, 7, 8 o'clock at night and say, hey, I'm really stuck on this. Can you help me with this tomorrow morning? I said, well, I can help you with it right now. And I can actually hop right into their account, because everything is shared with me. And I can actually show them, they're sitting at their computer, I'm sitting at my computer, we're on Zoom, we're talking through Zoom, and I'm going through and showing them exactly how I would fix that problem or where they went wrong. And we've got that luxury to be able to do that outside of our classrooms, for me at least, the first time in my career.
Yeah, I promise I'm not trying to turn this into an Onshape commercial, but that was so revolutionary. I mean, I was a full-time teacher during the pandemic, and I've had that experience with a student saying, I need help. And I say, hold on, I'm in your document right now. You can see my icon. Hold on, I'm going to click your icon. I can follow you, and we share a Zoom call, and we can be modeling in the same document at the same time using follow mode. And it does change the educational process. And so much of education is like timely feedback. And when you can hop on a model from your phone or whatever, I think that speeds it up. So I always enjoyed that.
I'm going to say, Matt, I use that as well with some of my older pupils. If we're all collectively drawing a design problem of some sort, I share a team with them and get them to share their models back into the team space, and then put them on the projector at the front of the class, and then they can all see their work live, being updated. And it just, I think it's really, really helpful, that, because then I can go, oh, I can see someone's sort of on the board, I can see someone struggling. So we talk through that as a class, and then we can get other people to step in and go, oh, why don't you try using this tool, or why don't you try doing that? And it just brings a bit more of collaboration. And I'm very keen as well to get pupils to help those that are around them. So I tend to put them in sort of helping groups, so pair or threes, and where they'll just support each other as well. And I think that using the collaboration's massive, because they can just keep building and improving, and I can just keep an eye on, or I can just go and stand next to them and support them. I don't always have to put it on the board, but I think being able to access everything live is brilliant. And like you, Steve, I did it during lockdown here as well. So my sixth formers, and we were sat both in the same drawing on a live Teams call, just chatting away, going, oh, why don't you try expanding that? Well, let's look at that face. Why don't you improve that? You can reduce that down, etc. And it's fantastic, you know, because it's just makes it so much more accessible on any device.
Agreed 100%. I really feel like the drawing aspect as well. A lot of the times I have the students get a partner. They're not in the same class, so they actually can't meet face to face during school time. They have to share drawings with each other and then attempt to model the parts off of each other's drawings, which really stresses the importance of hitting those standards and making sure that you're not missing one single dimension, because as we all know, you're missing one, it's unsolvable. So the students can really go back and forth and learn the value of a quality detailed drawing and how important it is to basically meet all those standards and have everything that is necessary on there. And I think that's honestly why we've hit the successes that we've had competitively, is because we don't miss those details, because they've been through it enough times where they know one thing missing is the difference between a solvable and unsolvable drawing.
Yeah.
It's amazing here. Go ahead, Philip.
I was going to say briefly along those lines, one of the things that I've seen very helpful in product development is taking a page from computer programming, where you do the exercise of pair programming, where you have two people who are programming together. And we do paired CAD on occasion. And with Onshape, we don't actually have to physically drag the chairs next to each other to look, you know, work next to each other in the same monitor. I've done paired design work with somebody who's not actually in the same time zone as me, but we can both be in the same model and we can see what's happening in real time and we can be talking. And it's when you've got a tricky problem to solve, that kind of collaboration can be very helpful.
Philip, you basically said what I was just about to ask. That's great. That's exactly what I wanted to hear. I was going to ask you specifically about your experience with collaboration and the kind of mindsets and skills that you want students to have heading at the university level and then heading off into industry, because it was incredible listening to Rachel and Steve describing the just workflows that their students are encountering. And to me, that's new. I think I went through most of my educational career doing well on tests, and then my first employer was the first, you know, my job was the first time I was ever asked to do anything. And so I had a lot of good tests I could point to, but I don't know if I'd ever gone through that, like the struggle of working through a design, especially working through a design collaboratively. And that's such a cool skill, an important skill. And so to hear that, you know, we've got 10 and 11-year-olds sharing documents, talking through dimensions, talking through the design challenges and running into each other and having to sit down there or not sit down next to each other and collaborate on a model is exciting to hear. And so, yeah, that I'm hoping that is setting those students up for success.
Oh, absolutely. Absolutely. 100%. You know, I think for us, especially within product development and working in high tech, where we're trying to translate some kind of promising technology into something, we're big fans of working with agility, which is all about, okay, I'm gonna make a hypothesis about what this thing should do or how we'd build it. And then figure out what's the most important part to test about it. And we'll do a little design spiral and we'll test that and we'll see how it works. And then we'll go back and we'll update our hypothesis. Did it work? Did it not work? We're not going to make a monolithic set of requirements and just assume that everything is going to work and proceed. So this kind of experience with students working collaboratively and getting quick feedback and then iterating a design, I think that's just gold, and it's going to serve anybody really well coming out of school, doing anything, whether it's for Silverside or other places.
I think you're going to have some resumes on your desk, Philip, pretty soon.
That sounds great.
Okay. Steve, I hope you don't mind if I quote you to yourself.
Sure.
I've heard you say that I've heard you say to your students, it is your job to do your best and it's my job to make your best better.
Absolutely.
And I love that quote. I'm going to use it. And I love that you're kind of diving a little bit deeper about specifically the role of the teacher in education in their role in, changing mindsets of students and changing like what their measure of excellence is. And so curious where your teaching philosophy came from. What does that look like in your classroom? A lot of the people here today are educators, and I think something I saw throughout my entire educational career is that educators are often kind of in their own little insular bubble. And so I'm hoping we can all kind of learn from each other's experiences. And so I would love to know, again, where that philosophy came from, what it looks like in your classroom. How do you improve the best of a student? And then finally, what are some of the fruits of that effort? What are some successes you've seen from your students?
Sure. Actually, that philosophy came from 9 years of being the head coach of a varsity wrestling program. So I was first year teacher, first year head coach, definitely lots of bumps in the road there. But as time went on, I actually started running my classroom very similar to a sports program, where I would start out with the freshman class or freshman team. Students would work their way through that, and if they liked it, they stuck with it and moved up to JV, and then they eventually moved up to varsity. And my job throughout that was to find the students that were willing to give their best and make sure that I was providing them with enough curriculum to keep taking it to the next level. So another thing that I think we all struggle with as teachers is going fast enough for the kids who get it and yet slow enough for those who might struggle. So that's always been the eternal struggle, I think, as us as educators. But the idea is that when I started running it more like a sports program and adding in the competitive aspects, many people have probably heard of Skills USA, which is one of the largest ones that we compete in annually. And you would get those students who would buy in because they had an opportunity to prove themselves. They had an opportunity to show how hard they had worked and to see the fruits of their labor, which we don't often get in a lot of other classes, including a lot of core curriculum. So that competitive aspect really, really helped drive things. And I tell my students regularly, you're competing for everything. You're competing for spots in classes. You're competing for spots at colleges. You're going to be competing for jobs. You're going to be in a pile of applicants. You are competing whether you like to compete or you're competitive or not. And that really has changed things in my class. I do 2 major competitions, as I mentioned, Skills USA, and then another one is a Michigan competition that we do where it's all project-based. And there are about 20 different categories of mechanical drawing that you can turn stuff into. And I love that competition because every student can get involved in that competition, not just a select few or the best of the best. Students are allowed to get involved in that and produce projects. They have all school year to work on them. We turn them in and they compete against other high schools at the state level. So that's a fantastic one. And I've really seen a lot of students who shy away from competition really blossom through that one because it can play to their strengths as well as their weaknesses if it's an area they want to improve in. So I really see the competitive aspect as something that really helps me make that best better. If I have a student that comes in every single day and listens to what I say and works to get better and wants to be the best at it, not only are they making the other students in the classroom better, they're also making me a better teacher.
Thank you for that. What is it about competition? Because I saw that in my class that I could ask my students, I'd give them a project and they would be so, their engagement would only be so high. And then I'd say, then at the end, we're going to do a competition, best one wins. And then the engagement just doubled, that they all wanted, if I just put up a leaderboard, that just seemed to increase engagement. And sometimes I felt like, am I just turning these guys into, fighters or
Right.
Chris, love to hear your thoughts.
So competition is great. I happen to love competition, but as I told Steve, not wrestling competition. That's just uncomfortable. The problem is what is best. In case of wrestling, it's pretty straightforward what best is. In the case of a real engineering problem, as we heard from the morning talk, best could be something that you don't realize is best at all. The idea of bringing CAD into an internet platform is would not have been considered best. Clearly, otherwise SolidWorks would have done it. So I think it sort of depends on what you want to define as best. And if you define best, then the students are going to be trying to replicate your ideas, right? Because they see you as a better wrestler than they are. If you define things that are clearly there is no best, then they're going to go in many different directions with it.
That is I'm writing that one down. Chris, do you have an example of that where a project or an assignment that your students were doing that maybe they took in a direction that you hadn't anticipated, and their best was not what you had anticipated, but ended up being remarkable or maybe even better than you expected?
Yeah, I have those all the time, because typically if you've got 20 students or 30 students, that's 30 different brains working on a problem. There's no way that I'd be able to match that. So clearly, if I allow them to be creative, their results are going to be much cooler than what I would have come up with. The key to creativity, though, is if you're going to be creative, you've got to take risks. If you're going to take risks, more than likely you're going to fail. The more creative you are, the more likely you are going to fail. So it's creating an environment where failure is lauded and pushed for if you want the creativity. As to an example, we had a bunch of interns working at the lab this summer. One of the things we wanted to do was actually be able to use, we do a lot of work with Lego. We wanted to be able to use the Lego robotic system to talk to GarageBand so that you could actually build your own Lego musical instrument and have it sound cool. And what was really neat is when they finally got the system to work, where we had BLE MIDI working, the entire lab got together and pulled together a concert and actually performed at the same time as a couple other members did a runway walk of some robotic infused clothing. So together, it was certainly not something I ever dreamed would have happened if you'd asked me what was going to be the end goal of the summer.
A runway walk or a Lego concert. And that's just one of those times as an educator, you lean back and go, I must be a genius because I just let these students do this. But it's really the student genius that's on display. That's two great examples.
I think one of the things too that I really love about CAD too is the idea that you can be creative on the design side and then be extremely specific and technical on the drawing side. And a vast majority of the competitions that we do are strictly based on the detailed drawings that are created and whether or not they adhere to ANSI and ASME standards. So it's really cool to see both sides of that. And I love that we can actually come up with one project that hits both that creative side where they have to design a solution to a problem and really foster that creativity. But then on the flip side of it, we can look at the drawing and say, okay, can this be made? And can it be made from the drawings that you produced? So in addition to CAD, I also teach an advanced manufacturing program where we're able to actually really truly test that out with 3D printers and CNC machines. So it's been a really cool aspect to be able to see both sides. I'm a CAD guy by trade, by nature, but I also teach that manufacturing class, and it has added a whole other fantastic dynamic to what I do in my curriculum.
So Chris said a key to this is a safe environment for students to be able to fail. How do you do that?
Same way you do it with a swimming pool. You toss them in and you're around to help them so they don't drown. It's believing in your students. A lot of faculty are hesitant to do it because you have to have this underlying faith that students actually will rise to the challenge. They always do. It's because you're now valuing them as a person as opposed to just wanting them to value you for your knowledge. So humans tend to respond well if they're valued. And so if you're valuing their ideas and their opinions, you get a lot more out of them, just like in the swimming pool or the wrestling mat.
Agreed 100% on that. I feel like a lot of us as teachers, especially first-year teachers, we want to spoon feed everything to our students. We want to break it down into little bite-sized pieces and feed it to them, and then okay, on to the next bite. And I learned very quickly, especially with CAD, this was not the right way to go. So we have to allow them to make those mistakes. We have to allow them to fail because that's how we all learned. Everybody in this meeting has made major mistakes before and learned a ton because of those mistakes. I usually try to stay a step ahead and anticipate the mistakes before they roll in, but I love that there are times where I am completely thrown off and have to figure out, okay, how did we get here? And then you actually learn about that student and the way that student thinks, which allows you to be a better teacher to that particular student.
Yeah, I think I would agree as well. And that's right across from age 11 to 18. You know, you can talk them through the basics and always start with a sketch, then go to extrude, then you're going to use this, this, and this. Then they'll go off on some sort of tangent. No idea how they've got there, but it's then sort of unraveling. that, and if they then can put that patience in to work it out, they are a ton better. The next model they make is 10 times better straight away, and they've already sort of pictured in their head how they're going to do that, and they know the tools they're going to use. And also, the peoples around them kind of go, oh, right, yes, and they're sort of learning off it as well. And I tend to find once one's made a mistake, and you can see the next pupil going and has hit that same wall, they go, oh, you need to press this button, or you just need to backtrack because your sketch isn't fully resolved, etc. And it does tend to bounce out. And I think with Onshape in particular, and sort of all CAD, give them the basics, but then let them have lots of free time, because they need to learn through failing. Even though it can be, like you said, Steve, really hard, because you want to just jump in there and go, oh, you do it like this because you know the answer. You've kind of got to stop and just help those that are really struggling, and let the others try and just work it out, but be there as their sort of safety net. And you definitely learn loads along the way, because there are numerous times where I've stood there and gone, I haven't actually got a clue how you've got to this. Leave the model with me, leave it with me overnight. I'll come back to you and have a chat to you tomorrow. And for us, it's a constant learning process as well. And it's no bad thing. I think that's good. So yeah, definitely game for carrying on with Onshape, definitely.
I have to imagine, at least from my experience, that's a minority opinion among teachers, that to trust, and like Chris said, to trust your students enough to allow them to go their own path. That when they, add a fillet, when you said not to, you could smack their hand and say, that's not what I wanted, or to respect them and trust them enough to say, all right, I'll let you run with that, and I want to see where you're going with that. That message is just so powerful to a young person, to say, looks great, go for it, buddy. And you might fail, but it's a safe place to do that. I'm also curious. Yeah, Philip, I was going to ask, what does that look like in the?
I think it's a really helpful skill to model to students, to provide that kind of freedom and flexibility to say, okay, here is what something needs to do, but I'm not going to tell you exactly how to get there. Because I've been really amazed sometimes working with students who are interning, doing a mechanical design problem, and some of the solutions that come up with, if I don't specify, I may have an idea in mind, but if I can separate the how of my idea from the what is its core does this thing need to do? If we're doing a coffee press or something like that for Jetboil, if you say, okay, we need to make a way for Jetboil to make coffee, we're going to get a crazy number of different ideas. Some of them may actually turn out to be pretty good. If we say specifically that it's got to be a French press coffee maker and it's got to have a metal filter and it's got to look like something, you're just going to be turning the crank, and you're going to miss out on that kind of creativity. So I think giving students an opportunity to separate out the, what does this functionally have to do from a particular way of achieving it, and then being able to explore different ways of doing something and fail and try again. I think that's really valuable.
Chris just put in the chat, I do remember as an educator, that's all well and good until you have to assign a grade, and differentiating in the classroom when you have to assign a grade. I'm not saying that don't do it, but that just presents another challenge when we're stuck with a system of grading. And I think a kind of what Philip said is maybe the part of the solution is that your grade is, can you make me some coffee? And how you get there, I'm gonna let you go. Because I remember, I'm full of biases. I spent 22 semesters at one university. That probably filled me with all kinds of biases. So letting them go their own path. Love that.
Well, and Steve mentioned that folks are going to be competing throughout your life. And although you may not be getting grades throughout your life, when REI, one of the big outdoor stores here in the US, puts a big picture of the coffee press accessory assembled backwards, because me, the design engineer, gave the user two different options of how to put it together. well, that was kind of a grade. I learned an important lesson from that. And we subsequently fixed the product, and you can't put it together wrong. But, I think the idea is it still worked out really well. It still made good coffee, but it was a good lesson for a young design engineer. And that just happens. And that's part of the trade. That's part of learning. That's part of living.
I get asked assessment questions regularly, and honestly, a large portion of what I take into consideration is the student's work ethic and attitude. Not every student is going to catch the ball when I first throw it to them, but if they're adamantly trying every single time to catch it, then I take that into consideration when looking at grading. But really a huge part of what I do now is self-assessment. So I let the student really reflect on what they did and actually tell me how they feel about the process, what they thought about their effort and their attitude. I explained to them through this process that I don't know how hard you worked. I don't know if this came very, very easily to you, or if this was something that you truly struggled through. I saw the beginning and I saw the end result, and I saw some of the in between while they were in class. But if a student especially is at home working on something or a larger project, I don't know what it took them to get from A to B to C. So we like having those dialogues with the student, and I like to let the student explain to me how they felt about the process and how they reflect on it. And students are actually usually very, very honest, and I'm fortunate to say that where I'm at, about that process, and saying like, hey, I really struggled, and then I backburnered it, and then I was rushing to try to get it done, so I came up with this solution, but I already know that I could have done this different and this would have came out better. And I look at that right there as a win-win for everybody, because that represents the real world and how things work. In industry, I think Phil would probably speak to that better than I would, but I would think that that's how things would work as well.
Yeah, I would agree. I'm also looking at the chat and folks talking about manufacturing, and I will say that one of the things that I try and do, and I was literally on our machine shop floor before I joined this call, working with a summer intern who's wrapping up a project. And I try and make sure that if you're designing something in CAD for us, I want to make sure that over the course of your employment for the summer or a different term with us, you're going to get a chance to actually build hopefully several different versions of what you've designed, because everything can look great in CAD, and then you got to go and put it together in practice, and you start learning all kinds of different things. And so I think to the extent that there's a way of tying the, hey, this is what the design idea looks like, and this is how it actually worked out when I tried to build it in reality, can be done. I don't know that it has to be a quote unquote manufacturing thing in education, but just the translating into physical reality, that kind of skill of seeing how you're going to build something is very translatable, and I think very helpful.
That goes hand in hand with what I think Mackenzie put a question in the chat about manufacturing, and that's the idea of can we design this on a computer, something digital, and then make it physical, and how do we make that happen? Because we've all looked at a model that looks great, and then if you went to actually make those parts or 3D print or CNC those parts out, there's no way that that's going to work in its current format, and you're gonna have to make modifications to be able to make that happen. So for me personally, what we do is we actually model everything in Onshape, and then we import it into Fusion 360 and set tool paths off of that. And the reason for that being that obviously I am a pro Onshape person when it comes to modeling, and I am definitely an anti-Fusion 360 modeling person, my own personal standpoint from personal experience. So we actually like taking it and porting it over into there, and then really seeing though how we're gonna have to modify that CAD model so that it can become something that can actually be manufactured in a CNC machine or 3D printed.
Chris, tell us about Kirimoto.
It's just a Onshape plugin that lets you actually 3D print or laser cut or CNC.
Mm-hmm.
Nice.
It's very useful.
Selfishly, I would love to know if anyone has any ideas about what we're talking about, the kind of disconnect from going from the virtual to the physical. I personally and my students, we're all really good at modeling in CAD, and then our robots fell apart when we made them. And so how do we close that gap a little bit?
Iteration.
Matt, if your students were interviewing with me, the first follow-up question I would be asking is, well, what did you do then? I'm kind of excited that your robot broke because you probably learned something. So I want to know what lessons you took away from that, and then what the next thing you did was, and did it fix it? Did it break again? Did you learn something else? Because that's the kind of person that I would be looking for, who can go and is going to encounter problems and be able to solve them working for me.
I'd agree.
In
And
fact,
once
I
again,
might be more
allowing,
interested in a dancing robot that kept falling down while trying to do the waltz than something that that did something less audacious perfectly well.
agreed. And just back to the idea of allowing them to fail. We were talking about how it's difficult to allow them to fail with CAD software. Imagine being in a machine shop and putting them on a CNC machine and allowing them to fail, knowing that they're operating an extremely expensive machine. So we use a lot of machinable wood early on, a lot of inexpensive tooling, because it's going to break at some point. And honestly, my students know, as long as they let me know it break or that it broke, that's not an issue in the least bit. You're not going to know what to do if you never break anything. I mean, all of us have fallen off of a bicycle. You have to fail to know what you're capable of doing. And so really just allowing that, expecting that, and letting it happen naturally is going to help them learn as they develop that solution, so that mistake doesn't repeat itself.
I think I would agree with that. We do quite a lot of outputs through either laser cutting or 3D printers, but also card modeling. So I might get them to output, if we're doing some sort of maybe furniture, the panels, just straight out as a scale modeling card, actually test it thoroughly. Does it work? Back to the CAD, iterate again, and double check it that way before you then go on to your finished material. So it is learning through failure, but that's part of the design iteration process. And I think that's really, really strong, because it will teach them an awful lot before then going on to a full-blown manufacturing company, definitely.
That's great. So I need to build time into my curriculum for that third, fourth, and fifth iteration till they get it right. Did I hear there was a waltzing robot? I'm curious to hear more about that. How does that work?
Yeah, that was my class during COVID, because the students couldn't come to class, so they had the robots come to class. We started with the Blue Danube. And then the music started, they had to find a partner and they had to waltz to the beat. And then when the music stopped, they had to stop. And being a Viennese waltz, of course, they had to rotate in the correct direction. None of this American waltz stuff. It was a lot of fun.
That sounds great. I want to go back a little bit to, I think it was Steve that said something about engaging the students also in the assessment part. So we've talked about how important it is to put students at the center of, allow them for choice in how they encounter the information and how they demonstrate that they get it, but all the self-assessment. I think that is part of, goes back to what Chris had said about putting students at the center. Have you guys, all of you, have you seen that maybe can contribute to more students, a broader range of students being successful, being engaged in class? Something I struggled with as a teacher was just who was entering my class and who was successful in my class. And it sounds like the more choice you can give, the more a broad range of students can be successful.
Yeah, I think I've found devices as a starting point. If you can offer iPads or any sort of tablet and a PC, that gives particularly my sort of middle-aged ones more options. And they're particularly like walking around the workshop while on an iPad as well, and just double checking bits while they're manufacturing. And I think also teaching them both ways is really good. So we'd start with the youngest teaching on iPad, but the older ones we teach via the PC. So they see both aspects. I also think with mine, I tend to I use videos to help support what they're doing, but then pull those away as they get older. So they're just getting little snippets, and maybe me doing a demo, and then it's learning through failure. So yeah, I think options and scaffolding is really helpful, but also pulling that away and letting them fail. So yeah, a bit of both.
I do a little bit of a different approach in that I think I'm trying to get away from this idea that everybody in my class learns the same material. It's sort of weird to think of, in an industrial sense, everybody in the company having the same knowledge set. You want a diverse knowledge set, and so can you in a classroom do the same thing, which means in a third grade classroom or a fifth grade classroom, your daughter might not be learning long division, but instead be doing the coding part. Your son might be learning long division and not getting to do the coding part. So it gets to be a bit of an issue in a classroom. But what it does is it goes from, if I have 30 kids in the class, that means I have, and let's say class meets whatever, 5 hours a week. That means I have 30 times 5 brain hours that I can use. If everybody's doing the same thing, I only have 5 brain hours, because they're doing the same thing, right? So suddenly your problems can be much more complex, and different kids will find different aspects of the problem that they're really motivated in or interested in. So very similar to a soccer team or to, you name it, Frisbee team. Different people have different specialties, which, if we get back to Alyssa's question of long ago, how do you assess something like that? How do you assess a soccer team? I mean, is the striker actually better than the goalie? So it does add for a difficulty there.
That's a great question, everyone. How far can you go down that road of differentiation? Because I mean, you're absolutely right. If everyone is doing the same thing, you're getting 1 hour per hour, and that's not an efficient way to get something done. And so if the soccer team wins the championship, I guess the whole team gets the trophy.
I think that's the beauty of some of these different competitions that are available. Obviously, this varies from state to state. Skills USA is a national competition, but that is all the students doing the same thing. The end result is produce a set of working drawings to ANSI standards. And that's the goal. But then finding project-based competitions, finding those creative competitions. And you've got to do some digging sometimes to find those. But if you can find those creative competitions and allow those students to find those different paths to find the solution to the problem, that just really opens up opportunities for everyone in our classes. So I really, encourage seeking out these creative competitions, these outside of the box ones. As much as I love Skills USA and we've had a lot of success at those, I really do like that outside perspective where all students can be involved and be able to find their own path to get to the finish line.
The goal of the class changes substantially, though. The goal of the class now becomes for you to understand how to speak to people that have knowledge you don't, and how to search out those people and work effectively with them, which I see as a much more useful goal in this day and age than long division or memorizing why we have seasons or stuff like that.
And it's good to hear that coming from a professor, because I feel like a lot of things I was trying in the classroom, I needed someone to validate this isn't crazy. Mackenzie has a great question in the chat right now. Could one of you share, so we've heard about the Waltzing Robot. Can one of you share a specific project? Because again, I think that's one of the things educators are gonna would enjoy taking away. A specific project that you've run with your students. And for Philip, it might be your favorite project you did as a student, or something cool you're doing at Silverside. I'm trying to model this. I'm trying to make it open. We're gonna take lots of paths to get to the answer to this question.
I can go first on that one. I have a year-long CAD class that I teach. At the start of the school year, the first day of school, the kids walk in, they know there's going to be a crazy project. They anticipate it, they know it's coming, and every year I've got to come up with something creative. Some of the things I've come up with over the years is we did a American Ninja Warrior obstacle course, where each student had to design part of the obstacle course, and then they actually had to animate it from a first-person perspective going through the obstacle course with all of the things moving and things that would be happening in real life if a person were to go through that. We've done pinball machines where they had to make a pinball game and actually had to animate it from a first-person perspective, the ball traveling through the machine. This year, don't tell my students, we're going to do Rock'em Sock'em robots. So I just picked up like 6 sets of Rock'em Sock'em robots, and we are going to rip them apart, and we are going to scan, measure, any way the students want to come up with a solution as to get some overall dimensions. They're going to go in and model, and then we're going to actually animate a match between the 2 robots. So all kinds of things. Last year, because of COVID, we got off to a little bit of a slower start, but we did PEZ dispensers. And they had to actually animate a compression spring, which if you ever try to animate a compression spring that is not cylindrical, it's a handful. But we worked our way through it, and we actually had to animate the PEZ dispenser opening and closing, the head flipping open, and PEZ coming out of it. So PEZ had to go in, close, head open, PEZ piece comes out. And the paths that the students took to get there, which is really, really impressive stuff. Really impressive stuff.
I feel like we might need to up our game, Steve. I haven't done any sort of massive Ninja Warrior type things, but I'm writing down a few top tips here.
Sure, we get pretty crazy, and action figures too. We did action figures where it was a team effort, and one student designed the head, another designed the torso, one in charge of arms, one in charge of legs. And the beauty of that was we had to make sure that everything fit together and would function. Yeah. So we had a couple action figures with gigantic legs, or huge arms, or a giant or small head. So working through that together and adding that communication and collaboration piece into it is huge. Because when I first started teaching, it was headphones in at your station, click, click, click. And I really wanted to break away from that and really make it more like a real life work environment where students were actually collaborating, student-led and collaboration throughout.
Yeah, I think what we do in the UK is perhaps a little bit different, because we don't necessarily just do the CAD in the secondary schools. That becomes part of the design and technology curriculum. So for us, the CAD would be, so we'd work through the designs, just pen and paper, then we'd move on to CAD as it becomes a more developed model. So one that I've done recently with sort of 13-year-olds is a really nice balance lamp made of multiple materials, a sort of plywood base that was just put together, but then an aluminium set of arms with a baked bean tin on the end. And what was really nice is the pupils who sort of got the assembly and the mating right could then get to animate it. And once he did it, there was like whoops going up all around the classroom. Because it's moving, it's brilliant. And it's that sort of just enjoyment, and you're like, yes, we've got it now. And they were the ones then that just sort of really ran with it, but then we're running around the class trying to help the other ones as well. So I'm definitely pinching a Ninja Warrior competition. I might just do that as a sort of mini module with
make sure you turn them in, because American Ninja Warrior actually hosts a competition that you can actually turn your designs in. And unfortunately, we didn't finish our projects in time. I think it was due in September or October a couple of years ago, and we didn't get it done until probably November. So we never got to turn those in, but I'd always wanted to see how they would have done had we.
Oh yeah. No, that's a great idea. And I think it's just another example of how you can use CAD just really well to sort of get some big collaboration in a class. So
and everybody thinks engines when they think of what we do. I mean, I feel like whenever I talk to parents, they're just automatically assuming that we're making car parts and engines. And that's like, no, CAD is everything. Everything that I see in the room I'm in right now, there's a CAD drawing for somewhere.
Yep, definitely.
I think some of the favorite competitions or design projects that I've seen are ones that have an end goal, but not a lot of specifics on how to get there. And so you see the great variety in how that works. And I'm thinking of one that I had to do in university studying mechanical engineering, which was to deliver the mail using a robot, and the mail room was in the basement. And so all these different teams are trying to get their robots up a set of stairs using all kinds of different crazy methods. Our robot grabbed onto the railing and rolled its way up like a gondola. This is called Talk to the Guys in the Machine Shop, because they have good ideas. And he says, there's a smooth way up the stairs if you could grab the railing. Okay. But it's fun seeing that creativity come out.
I would just move the mailroom, easier.
Well, file the building permit.
Philip, you may have heard this one. I don't know the story, so you'll have to Google it later. But there's some story about Niels Bohr and his like physics professor asked him, how do you use a barometer to measure the height of a building? And the expected answer was, you take the pressure at the bottom and then you take the barometer up top. And then he said something like, you just throw it off and time it.
Do.
I guess then you need a stopwatch. We have, I kind of can't believe it. We only have 4 minutes left. And so what I'd like to do with the last 4 minutes is just go around one more time. And if anyone just has, and again, our audience, both live and that will be watching the recording later, our audience is primarily educators who are looking for inspiration in their classroom, looking for projects to do in their classroom, looking for just a nugget of wisdom, something they can try to teach their students, a mindset, anything like that. So we'll just go around, and if you have just 30 seconds, a nugget to pass on to your fellow educators. And again, if you looked at the chat at the beginning of the meeting, we've got people from literally all over the world. And so if you could just share one thing, then we'll wrap up. Would anyone like to go first before?
I'll start.
Rachel starts, thanks.
I'll start with the sort of, if my younger pupils, what I tend to do is I will produce, if they're all producing the same thing in the class, so the same outcome, I'll produce an example model and share that with them as a view only. I'll also do maybe video in detail of how to do one part, and then maybe do a video, but in real time, no talking, so they can watch it, but not know everything, just as a supportive video. So I scaffold it, but don't give them all the answers. And then just upload that to some sort of thing that they can just watch it, like Shobi or Teams or whatever. In fact, I think you can embed it in Onshape as well, alongside the drawing. So I kind of give them part of the answers, but not everything. So that's my top tip for particularly the sort of 11, 12, 13, 14-year-olds.
Awesome, thank you.
Mine would definitely be to piggyback on that is allowing them to fail. We've said that a lot today, but also allowing yourself as a teacher to not necessarily even plan out what the finished product is going to look like. Almost allowing yourself to fail in a sense, to really give those students an idea of what they can come up with and how to get there. I've had a couple projects where I said to my class, I don't know how we're going to do this. I don't know how we're going to get there. But if we all work together and we do our best, I'm sure that we can get there. So allowing the students to fail and allowing yourself to be uncomfortable and put yourself in positions where maybe you don't have all the answers all the time, and be vulnerable and put yourself in those spots. And along with being vulnerable, the idea of competition. A lot of the teachers that I work with shy away from competition because if they don't do well, they think it'll be a negative reflection upon them. But it's the idea of putting the faith in yourself so that the students have faith in themselves and that they're not afraid to go out and compete, and they're not afraid to fail either.
That's great, thank you. Chris or Philip? Chris just pointed to Philip.
Yeah, my wife is an educator, and so my hat is off to all of the other educators joining here. And I would say, I think the things that I'm hearing today is just very encouraging, and to the extent that you as educators are able to encourage your students to interact with the world, to delight in understanding how the world works, learning how things interact with each other, learning how to interact with other people, and to explore that world. Who knows where that's going to take your students? I mean, not everybody needs to be an engineer like me, but having an understanding of technology and having an understanding of solving problems and how that applies is broadly applicable. And you look at the company that I work for, Silverside Detectors, was founded by a scientist and a public policy expert. And the whole point is to figure out how we can apply certain of this technology that he was working with to real policy applications. And that would be just one example of paths that can benefit from this kind of education.
Chris, you have the final word.
Excellent. So I would say there's three things I use to see whether or not I've had a successful class. One is whether or not I enjoyed it. That's probably the paramount. Two is what the solution diversity of projects is across the class. So did everybody build the same thing, or did everybody build different things? And then third is I look at the ratio of me talking to me listening in a class. as a metric of how much I'm trying to get them to follow my directions versus get them to think for themselves. And those all help me figure out how to make the class either go more on the creative side or more on the replication side, because both are necessary.